Okay, dear students, in the last period, we have studied about the salt. So, when acid and base are mixed in a proper proportion, salt and water are formed. We have majorly three types of salt: acidic salt, basic salt, and neutral salt. First, let us study about the acidic salt and its hydrolysis. So, let's move and understand the acidic salt. Generally, what happens? The pH of acidic salt is less than 7. We know that as the H plus ion concentration increases, the pH decreases. Salt formed from the weak base and strong acid is the acidic salt. So you can look into the example NH4Cl. When you allow ammonia and hydrochloric acid to react with each other, we get NH4Cl. At the same time, my dear students, when NH4OH, which is a weak base, reacts with the strong acid HCl, it gives us the acidic salt NH4Cl and water. When this acidic salt is added to water, now what happens? We have created or we have got the acidic salts. We want to add this acidic salt into the water. So when this acidic salt is added to water, it forms ions. So NH4Cl, when it is added to water, it forms NH4 plus ion and Cl minus ions. Now you know this is the anion from strong acid, whereas this is the cation from weak base. Cation from weak base. So NH4Cl produces two types of ion: cation, which is from the weak base, and Cl minus, which is the anion from the strong acids. Cation, so it when salt is added to water, it forms ions: cation from weak base and anion from strong acid. This salt NH4Cl is believed to be dissociate completely. So we think that all the concentration of NH4Cl has been dissociated into NH4 plus and Cl minus. So completely, cation from weak base undergo hydrolysis and forms the weak base in the water. So please remember, my dear student, that this cation, this one I'm talking about, this cation undergoes hydrolysis, undergoes hydrolysis. But remember, this Cl minus, which is the anion from strong acid, does not undergo hydrolysis. So we need to study the hydrolysis of NH4 plus ions. Let us see how the cation from weak base undergo hydrolysis, and it forms the weak base in water. So when you add, or when this NH4 plus ions are available, they undergo the hydrolysis process from water, and they add OH minus into them, and they form NH4OH and H plus. Now you must know, or you are well aware, that this NH4OH is a weak base. And we know that weak base ionizes in a very small amount or very partially. You will be, the Ka or Kb for this is of order of 10 to the power minus 5. So this, this NH4OH do not dissociate to give NH4 plus and H2O. So most of this NH4 plus NH4OH remains in the solution. As this NH4OH remains in the solution, it does not react. That means H plus ions, which are also created due to the creation of the NH4OH, they also remains in the solution. As they remains in the solution, they give us the, or they create the acidic character. So due to the presence of these H plus ions, my dear students, the solution of our NH4Cl is acidic in nature. Because these H plus ions remains into the solution, as this NH4OH does not react with the H plus, or NH4OH is not able to accept the H plus, and thus this H plus remains in the solution, which gives the acidic character to the solution of NH4Cl, then, and that is why it is called the acidic salt. NH4OH, which is a weak base, remains undissociated, and that is what it causes the H plus ions. To acidic solution, the pH is less than 7. And please remember that anion from strong acid, which is the Cl minus, does not undergo hydrolysis. So this is how, my dear students, we understand the hydrolysis of a salt NH4Cl, which is an acidic salt. So I hope, my dear students, it is understood. Is it understood well? Do you have any doubt? Thank you, dear students. So now let us study about the basic salt. You know, this basic salt is salt formed when weak acid and strong base reacts with each other. So we have this weak acid CH3COOH, which reacts with the strong base NaOH, which gives us the basic salt and water. Now we are well aware that, you know, this CH3COONA has two ions. One is Na plus and another is CH3COO minus. This CH3COO minus is the ion from the weak acid, and Na plus is the ion that is from the strong base. So Na plus, which is ion from the strong base, does not undergo the hydrolysis, but CH3COO minus undergo the hydrolysis, which causes OH minus to be produced, and these OH minus which are produced are the responsible for the basic characteristics of the salts. So now let us study this in detail. When basic salt is added to water, it forms ions, cation from the strong base and anion from the weak base. You can see that CH3COONA, when it is added to water, it produces Na plus aqueous and CH3COO minus aqueous. Salt dissociate or ionize completely. So anion from the weak acid undergo hydrolysis for weak acid in water to form weak acid in water. So you can see that CH3COO minus reacts with water again to produce CH3COOH and OH. This is what we are well aware, that it is a weak acid. As it is a weak acid, CH3COOH is a weak acid, so it remains undissociated and cause OH minus ions and leads to the basic character of the solution, that is the pH of the solution become greater than 7. Cation from strong base, which is there we have Na plus, does not undergo hydrolysis. So this is how, my dear student, we understand about the process of hydrolysis for the various types of salts. Now we want to study about the new type of salt, which is known as the neutral salt. Now this neutral salt can be of two types. One is salt formed from the weak acid and weak base. Another is salt formed from the strong acid and strong base. Let us first study the acid formed from the strong acid and strong base. So let us say the salt NaCl, which is produced from the strong base NaOH and strong acid HCl, that is your NaCl and water is formed. When neutral salt is added to water, it forms cation from strong base and anion from strong acid. We have already seen, my dear students, that cation or anion from strong base and strong acid does not undergo hydrolysis. Both anion and cation do not undergo hydrolysis, and that is why the pH of the solution remains 7. And this type of salt, which are formed from the strong acid and strong base, they are truly neutral salt, and their pH is found to be 7. Now, my dear students, we have the another type of salt. This type of salt is known as the salt that is formed from weak acid and weak base. So salt formed from the weak acid and weak base. We have the example of this salt that is formed from the weak acid and weak base is CH3COONH4. So CH3COOH and NH4, that is weak acid CH3COOH. This weak acid CH3COOH, my dear students, it reacts with the weak base NH4OH and produces the neutral salt CH3COONH4 and water. Now please remember that the salt which we have got CH3COONH4, this salt may be acidic or may be basic, may be neutral. So we need to determine the characteristics of this. But we can say that this salt can have. So how we can determine the pH? Let us understand. Salt from weak acid and weak base, when added to water, they produces cation from weak base and anion from weak acid. You can see here that CH3COONH4, when it is added to water, my dear students, it produces NH4 plus aqueous and CH3COO minus aqueous. Both these ions can undergo the hydrolysis because both are from the weak acid and weak base respectively. So both the ions undergo hydrolysis and produces corresponding weak acid and weak base. So both of them, they undergo the process of hydrolysis. You can see that NH4 plus, when it reacts with water, it produces NH4 plus and NH4OH and H plus. Same way CH3COO minus, when it reacts undergo hydrolysis, it produces CH3COO minus and H plus. So now it is necessary to determine which concentration is more, H plus is more or OH minus is more. How can we determine whether H plus is more and OH minus is more? That is what we can determine by finding the value of Kb and Ka for these weak base and weak acids. So both NH4OH and CH3COOH are weak base and weak acid respectively. So the product of H plus, the production of H plus and OH minus depends upon the value of Ka for CH3COOH and Kb for NH4OH. Now we have three conditions. If Ka for weak acid is greater than the Kb for weak base, pH is going to be less than 7, and the neutral salt which we have considered as a neutral salt, it is going to be acidic in nature. If Ka is less than Kb, then the pH is going to be more than 7 and the salt is going to be basic in nature. If Ka is equal to Kb, then pH is exactly equal to 7 and the salt is going to be neutral in nature. So pH of solution of salt formed from weak acid and weak base depends upon the K and Kb of weak acid and weak base. So my dear students, we can have two type of neutral salt. For one neutral salt, we can definitely say that it is truly a neutral salt. But still, for the another type of salt which we have considered it as a neutral salt, we need to determine, or we need to know the K and Kb value for weak acid and weak base, and depending upon the value of K and Kb, if the value of K is greater than Kb, then it is going to be acidic. If K is less than Kb, then it is going to be basic. And if K is equal to Kb, then the salt is going to be neutral. So this type of salt, which we consider, which is formed from the weak acid and weak base, still the acidic character of such salt is depending upon the value of K and Kb. So this is how, my dear student, we understand about the हाइड्रोलिसिस ऑफ सॉल्ट. इफ यू हैव एनी डाउट यू कैन आस्क मी. बच्चों अगर कुछ समझ में नहीं आया है तो आप लोग यहाँ पे मुझे पूछ सकते हैं, और वी कैन मूव फॉरवर्ड. ओके, then as we have seen that salt of weak acid and weak base may be acidic if K is greater than Kb, basic if Kb is greater than K, and neutral if K is equal to Kb. Now we need to understand a new term. Let us study about this term. And see, the new term is known as the degree of hydrolysis. So my dear students, let us study the degree of hydrolysis. How do we determine the degree of hydrolysis? Please remember, it is an important statement that the degree of hydrolysis is independent of concentration of solution. Please remember that the degree of hydrolysis is independent of concentration of solution, and pH of salt solution can be determined by their pK values, means pKa of the acid in pKb of the base from which the salt is prepared. So my dear students, from whatever the salt, from whatever the acid and base this salt has been prepared, we can find out the pH from the pKa and pKb value of this weak acid and weak base. For that, we write the formula pH is equal to 7 plus 1 by 2 into the bracket pKa minus pKb. The pH of salt solution can be greater than 7 if the difference of pKa minus pKb is positive. That means pKa minus pKb is greater than 0, and the pH of solution would be less than 7 if pKa minus pKb value is negative. That means the difference between pKa and pKb is less than 0. If the value of pKa and pKb is equal to 0, my dear students, the pKa minus pKb is going to be 0 and the pH of the solution would be 7, and we can say it is neutral salt. Now we have the next question to study, my dear students. Let me read the question for you. Question: the pKa of acetic acid and pKb of ammonium hydroxide are 4.76 and 4.75 respectively. Calculate the pH of ammonium acetate solution. So here we need to find out the pH of the ammonium acetate solution. We know that pH is equal to 7 plus 1 by 2 pKa and pKb value. We know that the pKa value for acid is 4.76. The pKb value for base is 4.75. So by doing this difference or subtraction, we get the value 0.01. So 7 plus 1 by 2 into 0.01 will give us 7 plus 0.005, which leads to the pH 7.005, which is slightly greater than the 7, and it is pH is equal to 7.0005. So we can say that the salt is slightly basic in nature. So this is how, my dear student, for the salt which is formed from the weak acid and weak base, we can find out the pH easily. If the value of pKa and pKb given, if they have given the value of Ka and Kb, we can calculate the pKa and pKb value, and by using this equation, we can find out the solution. So now, my dear students, we want to start studying about the new topic which is known as the buffer solution. Let us look into this buffer solution. Many fluids, especially the body fluids like blood and urine, have definite pH, and any deviation in their pH indicates the malfunctioning of the body. So when we do the laboratory test of our blood and our urine, and if the pH of blood and urine is found to be deviated, or then we can say that there is something wrong with our body and there is something wrong going on inside the body. The control of pH is very important in many chemicals and biochemical processes. The control in many chemicals and biochemical processes is very important. Many medical and cosmetic formulas require that pH of this formula, when prepared, must be constant. So when we are preparing some of the medical or cosmetic items, the pH must be taken care, and while preparing, the pH must be remain constant, and even after when they are used, the pH should be constant, and pH should be maintained constant while they are utilized or they are used. Now, my dear students, we are going to study about the definition of the buffer solution. The solution which resists the change in pH on dilution. Dilution means addition of water. Please remember that dilution means addition of water. So the solution which resists the change in pH on dilution or with addition of a small amount of acid or small amount of alkali are called buffer solution. So my dear students, the type of solutions which resist the change in their pH when you add from outside, if you add the small amount of water, that means if you dilute them, or if you add the small amount of base, which is also known as alkali, to them, they do not allow their pH to be changed, and these type of solutions are known as the buffer solution. Our blood and our urine are the buffer solution actually, especially our blood. Buffer solution of known pH can be prepared from the knowledge of pKa of the acid or pKb of the base, and by controlling the ratio of the salt and the acid and the salt and the base. So from this, my dear students, we would come to know that this buffer is prepared from the salt and acid or salt and base. Now let us see, and we can prepare the buffer of our own choice. So we can even determine the pH of buffer, or we can have the buffer of our own choice. We can maintain the pH of buffer, and we can create a buffer of our own desire or our own wish. Now let's move and understand the two types of buffer solutions. But please remember that the buffer is prepared from the salt and acid, or from the salt and base. That is what we can understand. We will study what kind of salt and what kind of acid, or what kind of salt and what kind of base we need. There are two types of buffer solution. One is acidic buffer solution, another is basic buffer solution. My dear students, let us understand about the acidic buffer solution first. Acidic buffer solution is prepared by mixing weak acid and its salt with the strong base. Please remember that when we take acid or base, we will take it weak. When we take acid or base, we will take weak. And when we take the salt, we will take the salt of the same acid when it reacts with the strong base. So we will take the salt from the species which we are using for preparing the buffer. Now let us understand it with the example. Example, a buffer solution of pH less than 7, that means it is acidic solution. A buffer solution of pH less than 7 is prepared by mixing acetic acid. We know acetic acid is a weak acid, and its salt with the NaOH. So when this acetic acid reacts with the NaOH, it produces CS3, COONA and H2O. You can see that. So this is the salt. Hello dear students, can you hear me? Hello dear students, can you hear
Yes.
me?
Yes, sir.
Yes.
Okay. So we can prepare the acidic solution, which buffer solution which is having pH less than 7 by mixing the acetic acid and its salt with NaOH, which is the CS3COONA, or we call it sodium acetate, in a proper ratio. We will study when we do when we derive the various formula to calculate the pH, that the ratio of this acid and salt are very much necessary to be maintained to a certain level, my dear students. So now we want to study about the acidic buffer solution and how does it works. Let's move forward. So first let us understand the buffer action, or the mechanism of acid buffering, or how acidic buffer mechanism, or how acidic buffer maintains its pH. As acidic buffer is prepared from the weak acid and its salt with the strong base, by mixing them in a proper ratio, my dear students, we can have this buffer solution. We can have this buffer solution that is prepared from by mixing CS3COOH and CS3COONA in a proper ratio. As we know that salt ionizes completely, this salt ionizes completely, and this acid being weak, it ionizes partially. Please remember, as we know that salt ionizes completely, almost completely, whereas the weak acid ionizes partially. Thus, weak acid obtains equilibrium between the undissociated acid as well as ionized ions. So you can see that this salt, this is the salt. This salt, we show it complete dissociation, and then after dissociation, the concentration of these ions are considered to be X and X. But this weak acid, my dear students, this weak acid actually cause the equilibrium between the ions which are formed, and thus if the initial concentration is C, then these two are 0 and 0, but after some time this concentration becomes C minus C alpha, and finally we get the concentration of ions of C alpha and C alpha. But my dear students, we know that this acid is undissociated or solid in state, and that is why there is no meaning writing the concentration for this acid which is solid in state. So you can see that there is an equilibrium established between the ions which are dissociated and as well as the weak acid which is into the solid state, my dear students. Now, my dear students, we can move forward and understand. The above is the buffer solution, and pH of this solution is determined by the concentration of H plus ions. So please remember that this is the acidic solution, and when we want to calculate the pH, we need to know the concentration of H plus ions, and these H plus ions actually determine the uh, determine the concentration, or sorry, determine the pH of the solutions. So the pH of the solution is determined by the H plus ion concentration. So now, my dear students, we have the acidic buffer in the vessel which we have filled. The vessel is closed, or the vessel is represented by the green boundary. We have maintained the volume of this vessel as 1 liter, and now from the outside, suppose we add OH minus ions, and from this OH minus from outside we add Y mole of OH minus ions. So now we are going to add Y mole of OH minus ions, or we can say we are going to add alkali. So this is addition of alkali into the buffer solutions. Now what happens when we add the extra ions from outside? The equilibrium of the weak acid get disturbed, and what happens in the 1 liter solution? This OH minus Y mole of OH minus ions react with the H plus ions which have the concentration C alpha, and they produce water, and they will produce the Y mole of water. Initial concentration was 0 for this water. When they react with each other, the concentration of H plus is decreased, and it turns out to be C alpha minus Y. All the OH minus are utilized, so the concentration of OH minus is 0 and Y mole of water is being produced. So now, my dear students, we can see the disturbed equilibrium where we have the total volume is 1 liter. At disturbed equilibrium, you can see that the concentration of H plus ions has been decreased, and now see the concentration of H plus ion is C alpha minus Y. Now what happens according to the Le Chatelier's principle? Undissociated CH3COOH dissociate to give the Y mole of H plus ions, and thus the no change of pH, or the pH is maintained. So now you can see that as the concentration of H plus has been decreased to C alpha minus Y, what happens? This undissociated CH3COOH again dissociate, again ionizes, and give more Y mole, Y mole of H plus ions. So we have written C alpha actually because C alpha minus Y plus Y, it happens over here, and the new Y mole of H plus are being produced. As the new Y mole of H plus are being produced, my dear students, you can see that CH3COO minus has also got its concentration C alpha plus Y. So the concentration of CH3COO minus increases, but the concentration of H plus remains the constant, and thus the pH of the solution is being maintained. So this is what it is, the important characteristics by which we can understand how the pH is being maintained when we add the alkali into it. Now in further what happens, this extra Y mole of CH3COO minus, they cause the common ion effect with the CH3COO minus. Thus the concentration of CH3COO minus, which is X, that is decreased to Y. They react with again Y mole of they react with again Y mole of Na plus 1 ions, and they give the CH3COO Na into the solid form, and thus the solubility of this salt decreases. And this is how we can say that this common ion effect decreases the solubility of the salt. Now, my dear students, we are going to see how the pH is maintained for the acidic buffer when we add the acid from the outside. So again, we have the solution where the equilibrium has been already been established. The volume is maintained 1 liter, and from outside we add Z mole of H plus ions. So when we